So now we'll talk about graphing reflections of functions. And it's going to be the same as we've seen before in general about functions, about when we reflect it, if the negative goes outside the function or the negative applies to the x first, how it's going to reflect. So for the function f of x equals the negative of log base b of x, reflects the parent function y equals log base b of x about the x-axis. So that affects the vertical part, so it's reflected, it's mirrored down. Or mirrored across, shouldn't say mirrored down because that obviously has some stuff below and some stuff above. Still has the same domain and the range and asymptote. For the function f of x equals log base b of negative x, so that negative applies to the x first, that's going to have the same shape of log base b, but it's going to be reflected across the y-axis. Now the domain is going to change to negative infinity up to 0. But the range and the asymptote remain unchanged. So here's a glimpse of that, or an illustration of that. The blue is the original function, the orange is the reflected function. So this is reflected across the x-axis because you had a negative out front. And then this is reflected about the y-axis. There's some data about this. So the asymptote stays the same. The x-intercept stays the same. Some key points, you get b inverse, or b to the negative 1, comma 1, and so on. Whereas over here, key point change would be negative b, comma 1. Okay. So if we're doing the negative out front, we draw the vertical asymptote, x equals 0, plot the x-intercept, reflect the graph of the parent function about the x-axis, and draw a smooth curve, which is sure a challenge for me, and state the domain and the range. If it's going to apply to the negative to the x first, you draw the vertical asymptote, plot the x-intercept, reflect the graph of the parent function about the y-axis, draw a smooth curve through the points, and state the domain and the range. So what we have here is we're going to sketch the graph of f of x equals log of negative x alongside its parent function. This says include the key points and asymptotes on the graph, state the domain, range, and asymptote. So we saw a log of x. Well, in the last problem, I think I did a log of x as the parent function. So for looking at g of x equals just the common log, or log base 10 of x. So it's going to go through 1, 0. It's going to go through 10, 1. So out here, it's going to go through 1/10 negative 1. So right about there. And of course, x equals 0 is the asymptote. So this is just the parent function. I'm not graphing the reflected function yet. So it's going to come up. I'm going to make the sound effects. Got it. Okay. So for the reflected function, I'll go to green. That's going to be on the other side there. So it's at negative 1/10, negative 1. It's going to be at negative 1, 0. It's going to be at negative 10, 1. So right about there. So it'll come up. Try to stay close to that y-axis. Okay, there you go. And that would be the graph of the reflected function, reflected log function.